Okay, I hear the recording in progress, so we'll share the screen. Okay, so finishing up 9.2 on Euler's method. I'll do one more of those and then we'll get started with 9.3. Okay, tomorrow you have a quiz. I'll have you do one of those slope fields. Okay, so be ready for a slope field kind of problem. And I'll also give you a problem involving 9.3. The separable equations that I'll start lecturing on today and a little bit more tomorrow. Okay, so the slope field, you'll have to make that array of 49 numbers, and then your xy plane that goes from -3 to 3 for x and for y. Okay, in fact, if you want to pre-make that, that's okay. You know, have it already ahead of time, so yeah, it's all good to go. All right, and then I should be done with the chapter. But I will get started in 10.1 next week, Monday and Tuesday. A heads up again, Wednesday, the 13th is a flex day, CSM flex day. There are no classes. And then Thursday, I'll review. If you have any questions, bring it up for review. And then Friday, the 15th will be exam 3, which will cover this stuff right here, okay? All right, so let me go back and do one more of the Euler's method, then I'll be done with Euler's method, and then go on to 9.3 separable equations. Okay, so we're in a little foray into differential equations. Okay, here's problem 21. Y prime equals y minus 2x. Yeah. Okay, delta x is 0.5, and they want you to do n equals 4. So y of 1 is 0. Where do we end up with by the time we reach 3? So if delta x is 0.5, I go from 1 to 1.5, 1.5 to 2, 2 to 2.5, 2.5 to 3. Now in the problem, it asks for y1, y2, y3, and y4. Let me just show you the wording. Okay, step size is 0.5. Okay, they give you the differential equation. Find y1, y2, y3, y4. So it looks like it's a different kind of problem, but it's still the same problem. Okay, you know you're going out to 2, and how do I know it's 2? Because you start at 0. Sorry, I take it back. You start at 1 this time. Say y of 1 is 0. So I go to 1 to 1.5, 2, 2.5, and 3. So I'm going to end up at 3 for x. Okay. So here's my interval. Y prime equals y minus 2x. All right, so I start at 1, 0. Plug in a differential equation to get the slope. So the slope m is y minus 2x. So 0 minus 2 times 1 is -2. Okay. And we know negative slope means the graph is falling. Okay, the ones I did yesterday, they were rising. They were increasing, but now it looks like we're going to be decreasing. Delta y equals m delta x. Put that in your cheat sheet if you wish. So -2 times the step size, which is 0.5. So -1. So my delta y is -1. So instead of a rise, I'm falling. Okay. So the next point is 1.5 comma -1. How did I get that? The new x is the old x plus delta x. Delta x is 0.5 all the way through. So I already know the x coordinates ahead of time. They're going to be 1.5, 2, 2.5, and 3. That's already guaranteed. The delta y's are the ones that we have to compute. What's my new y? The old y, 0, plus delta y of a -1. So I'm at 1.5, -1. And do it again. So what's the new slope? Plug into the differential equation, y minus 2x. So y is -1 minus 2 times x. -1 minus 2 times 1.5, -1 minus 3 is -4. So my new slope is -4. So it's negative. So we would have graphed this, instead of going up like the previous problems we did, it goes down. All right, so delta y is m delta x again. So -4 times 0.5 is -2. So I dropped 2 units. I was at -1. If I have a delta y of -2, well, now I'm at -3. So this graph keeps falling. So 2 comma -3. What's the new slope? Take that x and y, plug in here, y minus 2x. So y is -3 minus 2 times x is 2. That gives me -7. So in this case, it looks like it's getting steeper negative, right? It starts off with a slope of -2, then -4, then -7. So it's getting steeper and steeper as time goes by, it seems like. Delta y is m delta x, -7 times 0.5, -3.5. So I'm falling 3.5 units. Okay, yesterday we were always rising, right? I kept saying, oh, we were at a certain point, and then we would have risen a certain amount. So after rising so much, we end up at a new point. But now it looks like we're falling. All right, but you still do pretty much the same stuff. So my new m is -7. Delta y is m delta x. So -7 times 0.5, -3.5. So I drop another 3.5 units. So -3 minus 3.5 is -6.5. The new x is the old x plus delta x. But again, that's already predetermined. Right from the start, I already know I'm going 1, 1.5, 2, 2.5, 3. How do I know that? They told me the step size is 0.5. That's the delta x. So already, before I even start, I know it's going to be 1, 1.5, 2, 2.5, and 3 for the x coordinates. Right, so here we are. My new point is 2.5, -6.5. And then do it one more time, and then I'm done. So slope is y prime. Y prime means slope, or m, y minus 2x. So -6.5 minus 2 times 2.5. Punch it in your machine. The new slope is -11.5. Delta y is m delta x. So -11.5 times 0.5. Punch it in your machine, -5.75. So the last time I do this, the last iteration, 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 I drop 5.75. So that minus that is -12.25. So my estimate of y of 3 is the same as saying f of 3, is -12.25. So that's our guesstimate. All right, and that is it for 9.2. So I've shown you 3 of the Euler's method problems. I think 3 out of 6, so you do the others. And now I'm going to go on to 9.3, separable equations. And that's the last topic leading up to the next exam. So the next exam isn't just one chapter. Now we had just a chapter 6 test. We had just a chapter 7 test. This one is going to combine a sum of 8 and sum of 9. And then after that, they're just chapters, only chapter 10 and only quote unquote chapter 11. Although chapter 11, as you can see, is a pretty long one. All right, so 9.3 is on something called separable equations. Page 599. Special kind of differential equation. Whoops. There you go. So what do I want to do for separable equations? All right, so you get a differential equation. If you see y prime, write it as dy dx. And I say etc. because dy dx, that's only if the variables are y and x. But if you have s as a function of t, you might have ds dt. Or you might have u and w, then you have du dw, and so on. So that's what I mean by etc. Okay, this is a so-called Limenitz notation that you first had in Calc 1. Leibniz, L-E-I-B-N-Z. Okay, the D notation. Leibniz was one of the co-founders of calculus along with Sir Isaac Newton. Leibniz notation. Right, what you do is you try to treat dy and dx as variables, and then using algebra, try to write the equation so that you have f of y dy equals g of x dx. That means on this stuff, this side you have a bunch of stuff with y. That's not very mathematical sounding, but I think you get the idea. Everything on one side has y and a dy. Everything on this side is stuff with x dx. So you separate the y's from the x's, or the u's from the t's, right? Or the p from the w, whatever the letters happen to be. Okay, so all the variables on one side and all the other variable on the other. Then you simply integrate both sides. Okay, you just put an integral symbol. So it's almost like we're adding to our bag of tricks from algebra. If two things are equal, their integrals are equal, right? So you integrate here, integrate here. And then solve for y if possible. Now, if it's not possible, then don't even bother. And in some sense, that's actually better for you because it's less work. If you cannot solve for y, then don't. Just leave the problem alone. There will be some problems where you cannot solve for y, and you just leave it alone. Okay. All right, so if you see y prime, write it in the Limenitz notation, dy dx, or du dt, whatever. Treat dx and dy as variables, so multiply, divide, and whatnot. Okay. Have all the y's with dy, all the x's with dx. Then you integrate both sides. That's the basic idea. Then solve for y, if possible. Again, or whatever the letter happens to be. If it's u, solve for u. If it's p, solve for p, and so on. Okay. So let's just get our feet wet and try some of this. So 9.3, 1 to 19 odd, and 23, no graph, whatever that means. So look what 23 is. Yeah, so 23 has a graphing calculator icon. And of course, we already know, don't do any of that. Oh, I see. Don't graph the solution here. Okay. So it says 23B says graph, so you don't have to graph it. All right. So page 605, we have to go up to 23. So if as soon as I can focus this. So here are the problems. And some more. And some more. Okay. So solve the differential equation. So if you already have the Leibniz notation, dy dx or du dt or whatever, that's fine. If you don't have it that way, like y prime, just change it to dy dx. And I'll show you how that works now. Okay. Okay, dy dx equals xy squared. And I do not think this is an actual problem from the text. So I'll just make it a starred problem. Okay, so it's a good problem. In fact, this section, there's a lot of problems where I have to put a star, but they're not exactly the same as the old edition. Okay, so be that as it may. Dy dx equals xy squared. So it's sort of like number one. Yeah. All right, so there's a dy here, there's a dx here. I want all the y's on the left side, I want all the x's on this side. So that arrow means I'm dividing by y squared, right? Divide both sides by y squared, dy over y squared, and then multiply both sides by dx. So it ends up looking like this. Okay. And since you're in Calc 2, I trust your algebra skills are good enough that you know what I did. This arrow means divide by y squared. This arrow means multiply by dx. So you have all the y's with dy and all the x's with dx. Okay, so if you divide by y squared, I got all the y's on this side, multiply by dx. Okay, then I integrate both sides. So this becomes y to the negative 2 dy x dx. Right, so you separate the x's and the y's. Okay, so this is y to negative 1 over negative 1 plus c1. This is x squared over 2 plus c2. This integral has a plus c. This integral has a plus c. And then you may notice, well, this is a constant, this has a constant. I can put them together and then just say C. Okay? So from here on out, I normally will not put a C1 and a C2. I'll generally just go straight to plus C on the right-hand side. Don't have it on the side for the variable that you're trying to solve for, which is Y. Okay? So usually I'll just go straight to y to -1 over -1 equals 1/2 x squared plus C. And there's a C1 and a C2. Subtract over, you get a C2 minus C1, which is still just C. By algebra, this is -1 over y equals 1/2 x squared plus C. Multiply both sides by -1. 1 over y equals positive 1/2 x squared times -1 is -1/2 x squared. Okay, now here's something you kind of have to get used to. The fact that C is an arbitrary constant. C runs through all the real numbers. So algebraically, I would have minus C. Okay, but minus C runs through all the real numbers. So you might as well just leave it as plus C. Basically, you can sweep a lot of algebra under the rug when you have plus C. Negative C is still C. C plus 4 is still C. 2C is still C. E to the C is still C. Right? So if C runs through all the real numbers, so does negative C. It's still just an arbitrary constant. So, and that should be a must. You should write this as -1/2 x squared plus C. All right, how do I solve for y? I'm not sure you remember this trick in algebra. You are allowed to reciprocate both sides. If two things are equal, the reciprocals are equal. Okay, let's keep that in here. If A equals B, then 1 over A equals 1 over B. Right? So I reciprocate here, y, and 1 over the whole thing. So 1 over -1/2 x squared plus C. That's sort of correct, but you don't usually want to leave your answer as a complex fraction like that. So to clean that up a little, multiply top and bottom by 2. So y equals 2 over -x squared plus 2c. And once again, 2c should be written just as c. So this is my final answer. So y is 2 over -x squared plus c. So what we're doing is making our first attempt at solving a differential equation. Okay? So if we have separable equations, if we can separate the x and the y, some of you might look at this and say, okay, that wasn't that bad. Yeah, but very few differential equations are of this nature. Okay? If you were to take a course in differential equations, Math 275, you would not get a whole lot of these. I mean, you'll study separable equations, but that's a very small portion of the course. You'll have a lot of differential equations where you aren't able to separate. Okay? So again, we're really just doing baby stages of differential equations. I mean, just 3 sections, 9.1, 9.2, 9.3, barely scratching the surface of differential equations. Okay, and if you need more stuff on differential equations, take Math 275. The entire semester you're doing differential equations, right? All right, so that's my final answer. Please notice the form of the answer, which you're not used to. We are used to blah, 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 plus C hanging out to the side here. Okay. Here, the plus C does belong properly in the denominator. The algebra demands it. Okay, so I had the plus C hanging off to the side way over, where'd it go? Over here. But as the algebra developed, the C ended up being underneath here. So algebraically, it's not the same thing if you put the plus C way over here as opposed to here. So it should properly belong here. Okay, notice this is a whole family of functions. Just give me a different constant, a different real number, and this will work. And by the way, you can even double check this. I won't bother to do it this time, but you can double check this with show and tell, so to speak. Use this. Suppose the question says, show this is a solution to this differential equation. So you can try it. In other words, find dy dx, find xy squared, and you can show that they're always going to be the same. Okay. All right, I'm going to show you 5 star, which I notice is not the same as our 5, but again, it's close. y plus sine y, y prime equals x plus x cubed. Okay, so in some sense, this is kind of easy that you already have all the y's on one side and x on the other side, except for the y prime. Okay, so the rule is, if you see a y prime, write it as dy dx. And then this one's pretty easy to separate, just multiply both sides by dx, right? If you multiply by dx, then this has stuff with y dy, this has stuff with x dx. You want f of y dy, loosely speaking, stuff with y, g of x dx, stuff with x. Then I integrate both sides. And it even looks right, because over here, it's y plus sine y dy. And normally when you integrate, it's supposed to be a dy, right? And likewise over here, when you have a bunch of stuff with x, you're normally supposed to have dx, and it is. So even the notation works fine. Okay, then I just integrate y squared over 2 minus cosine y equals x squared over 2 plus x to the fourth over 4 plus c. So again, yeah, this should be blah, blah, blah plus c1. This should be blah, blah, blah plus c2. Put them together, c1, c2, but now we just leave it as plus c. And in this particular case, I'm done. I cannot solve this for y. So if you're trying to solve for y and you have a polynomial mixed up with a trig function, there's no way you can isolate the y, which is actually to your advantage because you can stop. You don't have to do any more stuff. You can't solve this. Okay, now, if I only have this, so solve for y, okay, I can multiply by 2, do square root, right? If you only have this, you can do an arc cosine, inverse cosine, right? But not when you have the combination. So what do I do with this? Just leave it alone. That's as good as it gets. So just stop there. Okay. Let's see, number 9 actually was assigned. So I'll show you number 9. Okay, dpdt is all this. So yeah, we don't have to use y and x. We could have dp dt is all this stuff. All right, I need to write all of this as a product. First thing I'm going to do is factor by grouping. Remember factoring by grouping? There's a common factor here of p, t squared minus 1. This already has t squared minus 1, so I'll factor out a 1, so to speak. 1 times t squared minus 1. By the way, you can double check. Multiply that out, you get that. Multiply that out. Excuse me. It's the same thing back. Okay, factor out the t squared minus 1, and you have this. So I was able to write it as a product. Something times something. And now I'm ready. Let's have all the p's on this side. So I divide by p plus 1, which is what I'm indicating by this arrow. And multiply by dt, which I'm indicating by this arrow. Okay, so dp over p plus 1 equals t squared minus 1 dt. Okay, so this arrow means divide. This arrow means multiply. Okay, of course, if you were my Algebra 1 students, I wouldn't go that fast, but you're taking Calc 2, which means your algebra is good, and you should be able to follow what I did here. Say, how did you go from here to here? Oh, divide by p plus 1, right? How to go from there to there, multiply by dt. So I get all the p's with dp. I get all the t's with dt. Okay, so separate stuff with y dy, stuff with x dx. In this case, stuff with p dp and stuff with t dt. Okay. All right, so this is ln, absolute value of p plus 1 equals t cubed minus t plus c. Solve for p if possible. This time it is solvable. First thing I notice is how do I get rid of ln? Exponentiate, right? So put the e down. E to the ln absolute p plus 1 equals e to the all this stuff. And then these guys cancel out. So absolute value of p plus 1. This side, I'm going to rewrite it as e to the 1/3 t cubed minus t, and then e to the c. I'm choosing to split it up. You might be unfamiliar with this step, but you're probably comfortable going the other way, right? Think back to algebra 1. If I have e to, I'll just cover it up. If I have e to something times e to something, you add the exponents, right? You would say, oh yeah, that plus that. Well, we're just going backwards. If I start with s, I can break it back into 1/3 t cubed minus t e to the c. And here's that tricky thing we said before. What is e to the c? If c is a constant, e to the c is still another constant. So I'll just sneak it in front and call it c. So I have absolute value of p plus 1 equals c e to the 1/3 t cubed minus t. Now, the next step looks really weird. Okay. I'll have to take some time to explain it, but if you just want to do it when it comes to a quiz or homework or test, that's fine. Take a look from here to here. I just dropped the bars, which is a valid step in this case. So how do I go from absolute value of p plus 1 equals c e to 1/3 t cubed minus t to just p plus 1 equals c e to 1/3 t cubed minus t? Okay, so I have to take a quick time out about absolute value. Okay, and I'll sneak that in over here maybe. So do you recall definition of absolute value of x? Well, it's the same as x if x is greater than or equal to 0, but it's negative x if x is less than 0, opposite of x. Lost my focus here, literally. This can be used as a definition of absolute value, right? Absolute value of x is the same as the number itself if x is greater than or equal to 0. It's the opposite of x if x is less than 0, right? All right, so let's take a look at what's going on here. Let me cover this up. Okay, absolute value of p plus 1. Let's pretend I have the top case, right? It's greater than or equal to 0. P plus 1 is greater than or equal to 0. Well, there it is. It's all good to go, right? I just dropped the bars. Absolute value of p plus 1 is p plus 1 if p plus 1 is greater than or equal to 0. Okay. How about the second case? Absolute value of x is negative x if x is less than 0. Okay. So suppose this comes out to be negative, then the absolute value would be the opposite. Okay, I'm not going to write it, but there's a negative in front of the whole thing. Okay. Put negative in front of all that, right? Multiply both sides by -1, you would have p plus 1 equals negative c, blah, 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 blah. But from what we said before, what is negative c? Negative c is still just c, still just a constant. Okay? So like we said, when you have c, you can do a lot of math and sweep it under the rug, so to speak. I can't just go straight from here to here. Okay, so if you didn't understand all that explanation, that's okay. Just know that when you get to this stage in solving these kind of problems, right, you can just simply drop the bars. But that's not true in general. Okay, so don't do every kind of absolute value equation from here on out and just say that I said you can always drop the bar. No, for this particular kind of differential equation, and the main thing is you have that c, which swallows up the positive and the negative case, then you're allowed to do it. Okay, but don't go back to your algebra 1 class and say, oh, my teacher said if you have absolute value, just drop it. No, in this particular case, you can drop it. Right, so it's a weird step. Okay, so whether you understood this or not, you're allowed to just go straight from here to here. I'll just mention quickly again the logic. If p plus 1 is greater than or equal to 0, there it is. If p plus 1 is less than 0, then you pretend there's a negative in front of the whole thing. Then multiply both sides by -1, and you have this, except there's a minus in front. So you have a minus c, but what's minus c? It's still c. Okay. Finally, just subtract 1, and you're done. So if I subtract 1 on both sides, p is c e to the 1/3 t cubed minus t minus 1, and that is my final answer. Okay. And then starting with problem 11, they give you an initial condition, right? Here, they don't give you that extra statement. Here they do, like y of 0 is 0, u of 0 is -5, y of 1 is 1, and so on. All of these final answers are going to have a c. These will not have a c because you can solve for c based on the initial condition. So instead of having a plus c, you'll solve for c, so you only have one function involved, if we can even say it's a function. And I'll show you how that works now. Okay, so let me show you 11 star, which is not the same as our 11, but it's close. dy dx equals x over y, y of 0 equals -3. So this is just like the previous set. But because of this, I won't have a plus c. I'll be able to solve for c. Okay, the fastest way to solve this is to cross multiply, right? That times that, that times that. So I can get the y with the dy, x with the dx. Then I integrate both sides. Y squared over 2 equals x squared over 2 plus c. Multiply both sides by 2 to clean this up. Y squared equals x squared plus 2c. And once again, what is plus 2c? Just c. Square root. When I do the square root property, I need a plus or minus. Yes, that is crossed off, and I'll explain that in a moment. But to isolate the y, I need right now plus or minus. So y is plus or minus the square root of x squared plus 3 plus c. Notice the plus c is underneath the radical. And that's not algebraically the same as having a plus c hanging out to the side here. All right, so this problem were like these, I'd be done. But now I can solve for c based on this initial condition. Y of 0 is -3. And by the way, if you ever forget, which one do I plug in what, maybe just cover this up. And now it says, oh, y is -3, right? So that tells me I'm plugging in for y. So this must be the other variable, x. Okay, so y of 0 is -3 means I put a 0 there, a -3 here. And furthermore, that now clinches that I'm doing the negative and not the positive. Okay, back here I had plus or minus. This here tells me it's got to be a negative. Okay? If I make it a positive, if I cover this up, -3 equals square root. That can't happen, right? So that's why in my final answer, I now throw out the plus sign and keep the minus sign, which is a little bit weird. I mean, a lot of times in your algebra, you threw out the minus sign and kept the positive, right? Sometimes there's a word problem. In a word problem, you cannot have a negative for some reason. But in this particular case, you cannot have the positive because of this, right? So there's got to be a negative. Equals, plug in 0, 0 squared plus c, which is c, square both sides, c is equal to 9. So final answer is one function, y equals negative square root of x squared plus 9. So it's one function only, which has two properties. Property number 1, it satisfies the differential equation. And I'll actually check that by show and tell. Property number 2, when I plug in 0, I get -3. That's easy to check. Let's do that right now. Plug in 0, you get -3, right? Negative square root of 9. So y of 0 is 3. Let's actually see is dy dx equal to x over y in this particular case. Okay. So in other words, what's the derivative of this guy, which is the same as -x squared plus 9 to the 1/2 power? So negative 1/2 x squared plus 9 to the negative 1/2 times 2x by the chain root. So that's negative x over radical x squared plus 9. Okay, and then the right-hand side is x over y. So what's x over y? X over the original function, x over negative radical x squared plus 9. And yes, indeed, they are equal by show and tell. Okay, so the original differential equation was this. Come up with a function so that the derivative is x over y. And when you plug in 0, you get negative 3. Here it is. When you plug in 0, you get 3. I found a derivative. I found x over y, and they were indeed equal. Okay. That's about it for that one. Okay, 13, and I'll stop with 13. du dt is blah, blah, blah. U of 0 is negative 5. Okay, so again, your final answer should not have a C for any of these, where they give you an initial condition, like y of 0 is 0, u of 0 is negative 5, y of 1 is 1, or whatever. Okay. All of these should have a plus C. Oops. These should not. The problems from 11 on should not have a plus C because you can solve for C. Okay. And yes, a reminder, the letters shouldn't matter. Don't get thrown off just because it isn't our favorite y and x. We could have u and t. So du dt is this, cross multiply. 2u du equals 2t plus secant squared t dt. Integrate both sides. U squared equals t squared plus tangent of t plus c. Square root, plus or minus. U equals plus or minus the square root of t squared plus tan t plus c. Solve for c because they tell me u of 0 equals negative 5. Okay, and how do I know which to plug into which? Sometimes you can cover this up and it says u equals negative 5. So negative 5 goes there, which means this must be t. So negative 5 is equal to, and again, there's a square root involved. So in order for the square root to end up being negative, I need to put the negative sign. So once again, I cross off the positive symbol. I keep the negative symbol. Negative square root of plug in 0 here, nice. Plug in 0 here, nice, because the tangent of 0 is 0. Negative 5 equals negative square root of 0 squared plus tan 0 plus c. That's 0, that's 0. So negative 5 equals negative square root of c. Square both sides, so c is equal to 25. Plug that back in here, and we're done. So the only one function which satisfies the differential equation and satisfies this initial condition is this one. U equals negative square root of t squared plus tangent t plus 25. Okay. So supposedly, I won't bother to check this time, but supposedly this satisfies the differential equation. You can double check that by show and tell. And the other condition is when you plug in 0, you get negative 5. That's easy to check. 0, 0, you get negative square root of 25, so negative 5. So that definitely works. Okay. Okay, can I explain the negative and the root? Okay, so we have plus or minus right here, same as the previous problem. Okay, if I put negative 5 here, right now it's plus or minus. Let me cover up the minus sign. Can this ever work? Let me just cover this also. Square root equaling a negative. No, that can never happen, right? For real numbers. The only way that's going to work, I had a choice of either plus or minus. It's only going to work if there's a minus now. So I have to get rid of the plus. Now, if it says u of 0 is positive 5, if this was a positive 5, then I keep the positive, throw out the negative. That was the same as the previous problem. Okay. I had a choice of plus or minus. But now once they say y of 0 is negative 3, so I know negative 3 is on this side. Okay. Behind my pen, I have a choice of either the positive or the negative. Okay. Maybe it's better if I just cover it up. Negative 3 equals square root, blah, blah, blah. Impossible. Unless instead of a positive, there's a negative in front. Okay, so that's why I keep the negative and not the positive. Okay. Another thing to say, cover this up. Can the u ever be -5? No matter what I plug in here, it might be easier to just cover it up and look at that. Square root of whatever equals a -5. Can't do it. You got to have a negative there. All right. So that's it for that. All right, folks, I'm done for the day, unless anybody else has a question. So again, tomorrow I will give you a slope field for the quiz. So you can make ahead of time that x and y and go from -3 to 3 for x, -3 to 3 for y, and make your grid ahead of time if you wish. And I'll give you one of these separable equations. I'll do more tomorrow, but I'll probably finish early so I can let you have some time to work on the quiz also. Okay, let me stop the share and see if anybody has anything in the chat. Otherwise, we're done for the day. Any questions, please? All right, that'll do it for today, folks. Okay, so have a good day, and we'll see everybody next time. Okay, bye, everybody.
Thank you.